I welcome you all for the wireless communication lecture modules. In this lecture, we are going to discuss about interference and system capacity. So, interference is a major limiting factor in the performance of a cellular radio systems. There are different sources of interferences are available. The first is another mobile in the same cell. We are making a call. Okay, so one more mobile in the same cell will create a interference with the another mobile. Okay, so a call progress in a neighboring cell. We are making a call in a or we are in a one cell. Consider a situation that another person is calling from the neighboring cells. So this is also possibility of getting interference. Okay, and another base station operating with the same frequency. If the two base stations are operating with the same frequency, there is a possibility of the signal gets interference with one another. Okay, and any non-cellular system which inadvertently leaks energy into some cellular bands. Any non-mobile system or non-cellular system that can also leak energy into that particular frequency band, no, that will also create a interference. So these are the sources of interference. Okay, so normally the two major types of system generated cellular interference, that is one is co-channel interference and the second one is adjacent channel interference. So first we will look at it, what is co-channel interference and what is the system capacity in case of co-channel interference. So the co-channel interference occurs because of the main reason due to the frequency reuse. So frequency reuse implies that in a given coverage area there are several cells which are operated at the same set of frequency. So in a frequency reuse, normally we are going to reuse the frequency in a particular geographical area. So more than one cells will be operating at the same frequency. So the cells which operate under the same frequency is called as a co-channel cells. So the interference among these two cells normally referred as a co-channel interference. So normally, if you have a thermal noise, that can be overcome by increasing the signal to noise ratio. Okay, if we increase the signal to noise ratio, obviously the thermal noise will effect will be evaded. Okay, so but in case of this co-channel interference, as if we increase the signal to noise ratio, obviously the interference between the cells will also gets increases. Okay, so we cannot reduce the co-channel interference by simply increasing the signal to noise ratio. So we need to maintain some other methods to reduce the co-channel interference. So to one way to reduce the co-channel interference is that the co-channel cells must physically separated by a minimum distance. Okay, so that we can provide a isolation between these two cells, so that the signal will not get interfere with one another. So by maintaining a proper distance or proper separation between the both cells, obviously we can reduce the interference due to the co-channel effects. So when the size of the cell is approximately same at the base station, and it transmits the same power, so for reducing the co-channel interference we need to consider two factors. One is the radius of the cell, which is normally denoted as r, and the distance between the centers of the two co-channel cells, that is denoted as d. So here we are considering two parameters. One is the radius of the cell r, and then the distance between the center of the core channel cell to the another cell. That that distance is denoted as d. So by increasing the ratio of d by r, okay, that normally referred as parameter q. Okay, so that is also called as co-channel reuse ratio. If we increase the co-channel reuse ratio, obviously the distance between these two cells will gets increases, that will reduce the interference. Okay, so this is the one way of reducing the interference. So while selecting the Q value, now the Q value has to be selected appropriately. A smaller Q value provides a larger capacity since the cluster size n is so small. The larger Q value improves the transmission quality due to the smaller level of co-channel interference. So either you need to select a smaller Q channel for the larger capacity, but you should to increase the transmission quality, now we should go with the larger Q value. We should have a trade-off between the smaller value and the larger value. Okay, so a signal to interference ratio is normally denoted as the given equation. A signal to interference ratio is given by S divided by summation of I equal to 1 to I naught summation II. Okay, so where S is the desired signal power from the desired base station, I is the interference power. So S is the signal power, okay, and I is the interference power. So the signal to interference ratio is denoted by this given equation. You know, so the average power received power at the distance of the transmitting antenna is the received power average received power is given by this equation. PR equal to P naught. Okay, D divided by D naught. D is the distance between this transmitting and the receiving antenna. D naught is the D naught is the distance from the smallest distance what we are considering for the transmitting antenna to the path loss component N. Okay, so in that way we can find the received power. So the signal to interference ratio it can be approximated with this equation with the help of a path loss. Here we are defining the power in terms of path loss component. So the signal to interference ratio is here. It is also uh, ec- uh, approximated with the help of a path loss component. And so signal to interference ratio is equal to R, that is the radius divided to the power of path loss component divided by the distance, that is also in terms of a path loss component. Okay. So if we simplify the equation 34, obviously we are getting to the signal to interference ratio, which is root 3 n. N is the cluster size, whole power path loss component divided by I naught. Okay. So this is about co-channel interference. Okay, next we will go to the adjacent channel interference. The interference resulting from the cells which are operating one adjacent to the one another. Because of that the interference is created. Then that interference is called as adjacent channel interference. So adjacent channel interference is from the imperfect receiver filters, because if we are using a proper filter, obviously we adjacent channel interference. This adjacent channel interferences occurs because of the improper receiver filters. Okay, so which can allow the which can leaks the uh, neighbor frequencies. That is the one reason for the adjacent channel interference. Okay, so the adjacent channel interference problem is particularly serious if an adjacent channel user is transmitting very close range to a subscriber's receiver, while the receiver attempts to receive the base station on the desired channel. That particular time, when the adjacent channel transmit the information, or when the user try to receive, obviously it tries to the user will receive this signal from the adjacent channel. Obviously that will becomes a interference. Okay, so this effect is called as near far effect. So a nearby transmitter captures the receivers of the subscriber. Unwanted, the subscriber receives the information from the adjacent channel instead of getting information from the own cell. So that is called as the near far effect. Okay, so now, alternatively, the near far effect occurs when a mobile close to the base station transmits on a channel close to being used by the weak mobile. Normally, weaker mobiles, weaker the signal mobile which have a weaker signal, that will be affected by the adjacent channel interference. Okay, so adjacent channel interference can be normally minimized by a proper filtering that can and the proper channel assignments. If you're assigning the channel far enough, or if you're keeping the separation between the adjacent channel frequencies far enough, so that the adjacent channel interference can be eliminated. Okay, so again, if the mobile, for example, if your mobile is closing mobile 20 times is closing to the base station as compared to the another mobile. Consider a mobile, two mobiles, one is very close to the base station when compared to the another mobile. It is the ratio of 20 times it is closer when compared to that mobile. So if the mobile has energy spilled out in a passband, the signal to interference ratio of weaker mobile. Weaker mobile means the mobile which is far away at the base station. Normally that mobile is called as a weaker mobile. So that weaker mobile will have a signal to interference ratio at the order of 20 times, because the distance between these two, that 20 times. So the 20 times of n is the path loss component. If you're considering a path loss component as a 4, so obviously the signal to interference ratio for the second mobile, weaker mobile, obviously it will become say 50 minus 52 dB. So if we want to eliminate the adjacent channel interference, we must reduce the 52 dB of interference between these two cells. Then only we can able to reduce the adjacent channel interference. So the separation after approximately 6 channel bandwidth is required for the typical filters to reduce the signal to interference as a 0 dB. So this is what, if you are considering path loss component as 4, and the distance between, if you are considering for the particular example, if you are considering the distance, obviously, then we are getting the, if you are, the filter has to work to reduce the attenuation of 52 dB, which is a very large one. This is a 6 times bandwidth, 6 times channel bandwidth has to be required for the filters to reduce that adjacent channel interference of the user. Okay. So this is about a adjacent channel interference. So in this lecture we are discussing about, to be summarize this, we are discussing about interference. Okay, so interference is not the thing is that an unwanted signal that will affect the user's performance, that is called as interference. There are two types of interference. One is a co-channel interference. Another one is a adjacent channel interference. Co-channel interference is the interference which occurs because of the cell using same frequency, that is called as a co-channel interference. Okay, the only way to eliminate the co-channel interference is by keeping these co-cells apart. Okay, by keeping some distance between these two, we can eliminate the co-channel interference. And adjacent channel interference is nothing but the interference between neighborhood cells, which are very little separation in the frequency. That interference is called as a adjacent channel interference. Okay, so adjacent channel interference can be eliminated by the help of, by using proper filters to attenuate the interference. This is about interference. We'll see the next thing in the next lecture. Thank you.